in example 7 and example 8, we're going to practice looking at these binomial experiments and identifying information. We're going to fill in the chart, and then we're going to use the chart to answer the questions about the probability. So in example 7, it says that a student tries to solve difficult puzzles, and the probability of solving one is 70%. So the probability of success in this case is 0.70, and success would be that he solves the puzzle. The two possible outcomes is that he solves the puzzle or he doesn't solve the puzzle. The student attempts 6 puzzles. That's why our variable x goes from 0 to 6. We could have 0 successes, 1 success, 2 success, etc., all the way up to 6. This is the binomial experiment. The binomial distribution is shown below. That's in the table where it shows all the possible values for x with the corresponding values for the probabilities. Let's see, we're going to complete the table and find the probabilities below. In order to complete the table, we need to know what this missing value is. What's the probability when x is equal to 3? That's what's missing. So in order to do that, we need to add up all the values and subtract from 1, and whatever is left over is going to be the probability for x is equal to 3. So we're going to take 1 minus 0.0012 minus 0.0101 minus 0.0546, and we're going to subtract also, let's see, 0.2965 minus 0.3025, and then the last one is minus 0.1176. When we subtract all those values from 1, we're going to get that the probability of x is equal to 3 is 0.2175. So let's put that in our table. Now we're going to use this table to answer the question. So part A, that's exactly what we just found. We were looking for the probability when x is equal to 3. So that's 0.2175. So for part B, we're finding the probability that x is greater than or equal to 4. So that means we're going to add up all the probabilities, including 4, that are greater than 4. So that's when x is equal to 4. Then we're going to add that to the probability that x is equal to 5, plus the probability that x is equal to 6. So for the probability that x is equal to 4, that's 0.2965, plus for x is equal to 5, that's 0.3025. And for x is equal to 6, that's 0.1176, which gives us a total of 0.7166. So the probability that this person solves the puzzle more than or equal to 4 times is 0.7166, or about 72%. Okay, so for part C, we're looking at all the values that are less than or equal to 2. Now that we're getting better at this, and we've done it a few times in the previous lesson and now, I'm not going to write out every single probability, so we're just going to look at the table and add them up. So we're going to find the probability that x is less than or equal to 2. So that would be the probability of 0, which is 0.0012. The probability of 1, which is 0.0101. And then lastly, we're not going to go over 2. 2 is our last number. Everything up to 2 and including 2. So that would be 0.0546. And when we add all of that together, we get 0.0659. For part D, we're looking at the probabilities that are between 2 and 5, including 2 and 5. So we're going to add 2, 3, 4, and 5 together. So we have 0.0546 plus 0.2175 plus 0.2965 and then plus 0.3025. Now, when we add all of that up, we get 0.8711. Okay, last example, the probability that x is not 6. So everything that's not 6, we would add up. So we would add up the probability for 0, 1, 2, 3, 4, and 5. Now, an easier way to do that might be less work, since it's everything except for 6, and we know the total of the probability should be 1, it's easier just to take 1 minus the probability of 6, which is 0.1176, and that will give us all of those values added up. All right, last example. It says a company tests each of its solar panels for durability. The probability that a panel passes the stress test is 48%. They test 5 panels from each batch. This is a binomial experiment. The binomial distribution is shown below. Complete the table and then find the probabilities below. Write all the answers in decimal format with 4 places when possible. Well, I must have already completed this for you. Less work for us to do. But if there was a missing value, we know that we would just subtract off from 1 to see what's left over. So our probability of success in this case is 0.48. Our number of trials is 5. They're testing 5 panels. So let's take a look at these parts. So part A says find the probability that x is equal to 2. So that means find the probability that 2 panels pass the stress test. So that probability, looking at the table, is 0.2743. In part B, we have the information to do it. It's just different than what we've been looking at. We're doing this in reverse. In this case, we're given the probability is 0.0312, and we need to find the value of x. What is the number of successes that gives us the probability of 0.0312? And that would be x is equal to 0. When we look at the table up here, we can see x is equal to 0 gives us a probability of 0.0312. Okay, finding the probability that x is less than 3. So that's any of the values of x that's less than 3. So we're going to add 0.0312 plus 0.1454 plus 0.2743. We're going to include 3 in this case because it says less than or equal to 3. So we're going to add in the 0.3074. If it said strictly less than 3, then we would stop at 2. Now, when we add all of those together, we're going to get 0.7583. All right, part D says, find the probability that x is between 1 and 4, including 1 and 4. So we're going to add 0.1454 plus 0.2743 plus 0.3074 plus 0.1790. Now, when we add all those up, we get 0.9061. So that's telling us the probability that the panels that are tested will have between 1 and 4 successes. So for the last part, x is not equal to 5. We could add everything up from 0 to 4, add everything up, because those are all the values that are not equal to 5. Or, to make it easier on ourselves, we can just find the complement. So, I would take 5, which is 0.0627, and subtract it from 1. And what's left over is going to be everything from 0 to 4. When we do that, we get 0.9373.